video on YouTube. Okay. So once again, good afternoon, everybody. So this afternoon, we will be studying descriptive statistics. All right. So we'll be studying descriptive statistics, and last time, in your unit module, no, you have encountered there several formulas, okay? But this afternoon, I will not bore you with the different formulas or computations for the different measures of descriptive statistics, like the measure of central tendency, measures of variation, and measures of position, okay? So today, I will be discussing to you the a conceptual approach of these three measures of descriptive statistics, because at the end of the day, when you do your research, when you do your paper later on, you'll not be doing manual computations. Okay, what we're going to be doing is a computerized computation, a digital computations of statistical tests. In other words, in the next weeks, I will be introducing to you, and yeah, maybe later, okay, I will be introducing to you a software that we will be using in analyzing your data set. Okay, it's called SPSS, or Statistical Program for Social Sciences. So we're going to be using that in analyzing your data, in processing your data, and you're encoding your data. Because we're having I mean I'm thinking about starting your research subject. Okay, the topics under research, because this subject is Introduction to Research and Basic Statistics. In other words, I have to introduce to you the basics of research. All right. So at the mid of November, I am planning that you begin doing your paper already. Okay, you begin doing your paper. At least maka-come up tayo ng title and statement of the problems, and we can gather data out from those problems. Okay, we can gather data out from those problems, and you'll do statistical analysis of your data. So I am planning that that's gonna be mid of November, so that until December, before the Christmas break begins, we can gather data already, and you can already start analyzing your data. In other words, we're gonna fast track our discussion on statistics. In the next weeks, you're not gonna encounter anymore the same modules that I am sending you, but it's gonna be practical. We're gonna be having synchronous sessions every week, okay? So every week ng ating synchronous session, kasi gusto ko na matutunan nyo talaga kung ano nga ba ang kailangan yung gawin sa statistics, at ano nga ba ang kailangan yung matutunan, okay? Ano kailangan yung matutunan at magagamit nyo talaga pag kayo ay magre-research na. Okay, so that's gonna be for the next weeks. Although, kahit na walang module, andun nga yung synchronous sessions natin, meron pa rin kayong mga quizzes every now and then, okay? As a measurement of how well you have grasped our discussions during our synchronous session. So kaya nire-record ko ito dahil doon sa mga walang pang load, o kaya doon sa hindi makapunta o makamit, maka-join ng ating meeting for this afternoon, pwede nilang panoorin ulit. Okay, pwede nilang panoorin ulit sa YouTube, at hindi sila ma-behind sa kanilang understanding. So as I have mentioned, we're gonna be discussing today the concepts of descriptive statistics. So less computation, although it is important that you know it, because in the examination, in the quiz, may mga computations pa rin, pero not as difficult as what you have encountered in your unit modules. All right. So in the previous discussions, in the previous synchronous sessions that we have differentiated descriptive statistics and inferential statistics, the two branches of statistics. So let's have a review of that now. If we have a person here, okay, and we're interested in getting the height of the person, okay, the height of the person, what else? The weight of the person, or maybe the age of the person. What we're actually doing here is that we are describing the person. Okay, we are describing the person. In other words, the questions on what is the height of the person, what is the weight of the person, or how old the person is, you're answering questions on descriptive statistics. Okay, you're describing that person. That's the essence of descriptive statistics. In other words, we are running the different measures of descriptive statistics to describe our variables. Okay, to describe our variables. All right. Now, but if you have another person here and you are getting the same variables from this person and you wanted to compare this and this, that is no longer answerable by descriptive statistics. Instead, those questions are answerable now by inferential statistics. Okay? So whenever we compare two variables or the other, okay, we're not doing descriptive statistics anymore, but we're doing inferential statistics. For example, is the height of this person different from this height of this person? Or is the age of a person this related to the weight or the height of the person? So those questions are no longer answerable by descriptive statistics, but they can be answered by statistical measures under inferential statistics. Okay, inferential statistics. So this afternoon, we're going to be dealing with descriptive statistics, and we're going to be discussing the three basic measures of descriptive statistics. And we begin with the measures of central tendency. All right. So in your unit module, you have encountered three measures of central tendency. We have the mean, we have the median, and we have the mode. And they were symbolized as X bar. Median is X with a wavy line on top of X, and then X with a, I don't know how to call this, but it's like a triangle on top of X. That's the mode. But sometimes in books you can see this symbol like this one. This is mu. And even though mu and X bar are different in terms of their appearance, both of them refer to the mean. Okay? Both of them refer to the mean. But this one is a sample statistic. Okay? This is an statistic, while this one is a parameter. Okay? In other words, people, if we get the mean from a population, our symbol should be like this. Okay? But if we get the mean from a sample, okay, from a sample, our symbol is X bar. Because this is the statistic and we refer this again to our sample, no? As what we have discussed in our previous sessions, while this comes from a population. That is why, if we compute for the mean of a sample, our formula is summation of our values over n minus 1, right? This refers to our size minus 1. But for a mean, the formula will be summation of x over big letter N. And this represents a population. However, even though they are not the same, they are not the same, in terms of their appearance, this is X bar, this is mu, and the formulas are also different, it still refers to our mean. It still refers to our measures of central tendency. And most of the examples that we will be dealing with is a data coming from a sample. Okay? Kaya makikita nyo, no, ito yung degrees of freedom kasi na sinasabi natin eh. DF yan eh. Degrees of freedom eh. So in other words, itong N-1 yan, you will encounter that most of the time when you're dealing with a sample. Okay, when you're dealing with a sample, with a statistic. But with a population or a parameter, you're not gonna be seeing this, but you're gonna be seeing big letter N. All right, big letter N. So those are the measures of central tendency. We have the mean, the median, and the mode. Let's discuss them individually. Okay. Now, when we talk about the mean, people, the mean is simply referring to your average, to the average value. Okay, to the average. The median, on the other hand, will refer to your middle value. Kaya nga siya tinawag na median kasi walang ilaw. How is this? Sorry. Can you still hear me?
Yes, sir.
Yes, sir.
May ilaw din ba sa inyo?
Meron po, sir.
Meron?
Wala, sir. Wala na pong ilaw, sir.
Meron po dito
Wala
sa
po,
meron.
sir.
Sige, ganito na lang. I'm gonna use up my battery. Hanggang kaya. Wait lang ha. Set up ko lang to. Okay. May ilaw na. Okay, can you hear me?
Yes, sir.
All right,
Yes,
let's
sir.
resume, no? So the median is the middle value, while the mode, okay, the mode is the most frequent value. Okay, the most frequent value. In other words, no, in other words, pag sinabing average, i-add natin yung values natin divided by the number of values. That's simply the average. In other words, pagka kukuha ka ng grade mo, kunwari pag meron kang certificate of grade at ang ginagawa mo ay ina-add mo lahat yung grade mo tapos divided by the number of subjects, what you're getting is actually the average. Okay? Actually the average. Now, the middle value naman, the median, you arrange the values lowest to highest or from highest to lowest, and you get the middle value. You're getting the middle value or the median. And then the mode naman, the mode, okay, the mode, it can be done through visual inspection ng data. Titignan mo anong values ang pinaka nag-a-occur, pinaka frequent na value doon sa dataset mo, and you can get the mode. Okay? Sometimes you get 2 modes, you get 3 modes, so yung mga sometimes you don't get any mode at all, di ba? So wala siyang mode, so zero mode, or pwede ring dalawa, bimodal, di ba? May tinatawag tayong bimodal, meron din tayong tinatawag na trimodal, at pag mas marami sa tatlo pa yung mode mo, pwede siyang matawag na multimodal. Okay, multimodal. All right. Now, why is it important that we understand this means this a measure of central tendency? You have to understand that not all types of data can be treated with any of these measures of central tendency. Kasi meron tayong mga data, depende sa levels of measurement, na akma dito sa ating measures of central tendency. Okay? Halimbawa, if I am studying, the BMI of my first year students, and I would like to relate this to the sleeping time, okay, to the sleeping time of my respondents. Okay, I would like to relate it. In other words, I would like to know if ang sleeping time ba meron siyang relasyon sa BMI ng aking mga estudyante. Now, the BMI of my respondents can be represented by the value, yung nako-compute mong value doon sa formula ng BMI. Or, you can actually categorize the BMI, di ba? Meron siyang categories like normal, below normal, at meron yung obese. I don't know kung anong categories pinag-aaralan nyo yan, so dapat alam nyo. So, hypothetically, no, categorize lang, categories. So, ang BMI, you can describe it through a value, yung computation nyo, at yung category ng BMI. And also, I am interested in getting the sex of the respondents, the age of the respondents, and perhaps I would like to also know their income, okay? Family income, okay? Family income. So these are other variables I am interested in getting at, and I also would like that these variables are related to BMI. So meron bang relasyon ng sex, ang age, ang family income sa BMI ng aking mga estudyante? Now, sabi ko nga, measures of central tendency would describe the variable, describing the variable. So I have here my variables BMI described by a value or a category. Now, question. What level of measurement itong value na sinasabi natin dito? Anong level of measurement ng value? at anong level of measurement ng categories natin of BMI. In our previous lesson, we have identified 4 levels of measurement: nominal, interval, ordinal, and ratio. Now, in terms of the value, what is this? Is this ordinal? Is this interval, ratio, or nominal?
Interval, sir.
Now, this is an interval value, interval scale of measurement. What about categories of BMI?
Nominal.
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 Okay. What about sex?
Nominal.
Nominal pa din yan, right? Okay, nominal pa rin ito. Okay, what about age? This is?
Ordinal.
This is
Ratio.
ratio. While family income is also ratio.
Ratio.
All right? So it is
Ratio.
important that before you identify kung anong measures of central tendency ang gagamitin mo to describe a certain variable, that you know the levels of measurement of your variables. Because not all these can be used to all types of variables. For example, let's look at the categories of BMI of our respondents. Let's say kung normal siya, 1. Kung below normal, 2. Kung obese, 3. Okay? And I have, for example, 10 respondents. 1, 2, 3, 1, 1, 2, 3, 1. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. All right. So imagine, okay, or let's say that these are the BMI of my respondents. 1, 2, 3, 1, 1, 1, 2, 3, 1, and 2. So it means na ito natin, yung normal natin is 1, yung below normal 2, yung obese naman ay 3. All right? Say for example, that those are my data. Those are the BMI of my respondents. Question: what do you think is the most appropriate measure of central tendency that would describe all my respondents?
Mode.
Yes.
Mode.
Okay. Yeah, you were answering that it is the mode. Why? Because if you look at it, the mode is equal to 1. In other words, most of my respondents are normal. Now, let's try getting the mean of these values. So let's try to get the mean, no? 1 plus 2, 3. Plus 3, 6. Plus 1, 7. Plus 1, 8. Plus 1, 9. Plus 2, 11. Plus 3, 14. Plus 1, 15. Plus 2, 17. Okay? And divide it by 10. So we have 1.7. Question: does 1.7 mean anything to you? Meron bang ibig sabihin itong 1.7 na nakuha nating mean? Oh, relevant to our categories of BMI, right? So if we get the nearest whole number from 1.7, we get an estimate of 2, right? We get an estimate of 2. And if we get the mean, we get the representation of that is below normal. Now, what if my analysis would be most of the respondents are below normal? Dahil ang na-compute kong mean ay 1.7 or which is near to 2, which is below normal. If that is my type of analysis, if that is the way I analyze my data, that is very incorrect. Dahil it does not give justice to most of your respondents. Kasi nga, ilan ang 2 lang? 3 lang, oh, versus 1 na 5 sila. Okay? In other words, it is not, these measures of central tendency cannot be used to all types of data. You have to examine first the levels of measurement of your variable and then choose which measure of central tendency should you use. Okay? Now, in terms of value, in terms of age, and in terms of family income, the most appropriate measure of central tendency there is the average. Okay? Is the average. So when your levels of measurement are in ratio level or in interval level, okay, in interval level, the mostly used measures of central tendency is the average. So like for example, age, okay, age. So you can have a non-whole number value for the mean of the age, and that still makes sense. Okay, that still makes sense. But if you get a non-whole number value for a certain category, for a certain categorical variable or a nominal variable, well, it doesn't make sense if you have a a non-whole number value for that matter. Okay, so basically my point here is that it is important that you know the levels of measurement of your variables in order for you to identify which measure of central tendency should you use. Okay, now sir, ano naman at kailan ginagamit ang middle value o ang median? Okay, sometimes our data is so peculiar. Okay, in other words, merong irregularities sa ating data. Halimbawa, ito yung score ng mga bata in an examination in statistics. Okay? Let's say it's up to 20. Okay? So 2, 4, 6, 8, 10, 12, 14, 18. For example lang for example. Okay, for example, now, if you look at this set of data, you can see that most of the scores are in this part. Okay? Are in this part. But there are also scores in this part. Okay? There are high scores in this part. Now, kung kukunin natin, ang mean, okay, ng scores na to, the tendency is it's gonna be high dahil marami ang nasa part na ito. Okay, marami ang nasa part na ito at yung values niya sobrang laki. Okay, 20, 18 and 14 compared to 2, 4 and 6, even though marami sila dito, the values here can surpass the number of values or the total number, okay, or the total scores of students in this part of our how do you call this diagram? Dot diagram. Okay, this dot diagram here, kahit na marami sila dito, but the values are very small. So pag in-add mo yan, dahil marami pa rin, considerable pa rin yung number na nakukuha ng maraming values dito at matataas yung values, the tendency is the x is gonna be high. Okay? The x is gonna be high. And the tendency therefore, kung ganun ang mangyayari sa atin, hindi natin mabibigyan ng description itong mga values na nandito. Alright? So even if sabihin natin ang magiging mean natin ay 14, di ba? 14. So sasabihin mo kay principal ngayon, "Ma'am, maganda yung performance ng mga estudyante ko kasi yung mean namin ay 14. That is above the passing score." Nakalimutan tuloy ngayon o nagiging negligible yung resulta na marami sa mga estudyante mo ang less than 6 ang nakuha. Okay? Ang tawag natin sa mga data na katulad nito ay meron tayong mga outliers. Okay? Meron tayong mga outliers. Ang outliers, ito yung mga extreme values. Okay? Extreme values like very high or very small values sila. Okay? It can be very high values or very small values. Ang tawag natin sa kanila ay outliers. Okay, outliers na nakakaapekto ngayon sa value ng ating mean. So instead of you having a normal value for mean, ang nangyayari, nagiging extreme din yung value ng mean mo to the point that it cannot represent the whole of your variable. Okay, because of the outliers. Now, in this case, dahil meron kang outliers at ang dami ng outliers mo, ang ginagamit natin ay yung median value. Okay, ang ginagamit natin ay yung middle value. Pero in rare cases ito. In rare cases. Only if there are so many outliers that you use the middle value. But that happens in rare cases. I'll give you an example. Now, for example, this is your grade in first semester. And then suddenly may grade ka na 72 at 75. All right? Now, you have a grade of 72 and 75. Now, if you add this together and you get the mean, okay, you get the mean, that's gonna total to what? Let me compute. So that's 92 plus 93 plus 94 plus 92 plus 90 plus 72 plus 75 equals divided by how many? 1, 2, 3, 4, 5, 6, 7. You'll get a score of 86.86. That is your mean. Oh, that is your mean. Now, the problem here is that, you see, these are our outliers. Okay? These are our outliers. Dahil sobrang baba ng values na ito, naapektuhan tuloy yung grade mo na mas maraming line of 9. Okay? Ang tawag natin dito ay outliers. These are values that severely affects the stability of your mean. Instead of having a mean na line of 9 din, ang nangyayari dyan, titignan natin, you look, dahil sa outliers mo, naapektuhan ng significant, okay, ng sobra, yung value ng iyong mean. Alright? Yung value ng iyong mean. So sa mga ganitong pagkakataon, no, ang ginagamit natin ay yung median value. Why? Because the median value is stable. Okay, the median values is stable. Kahit dagdagan mo to ng values na mataas o mababa, the median value will stay in the middle. So let's take this for example. Kung i-arrange natin yan from highest to lowest, lowest to highest, 72, 75, 90, 92, 92, 93, and 94, our middle value will be 92, right? And 92 would be the value now that would describe all of your grades. Okay? So instead, kahit na meron kang 72 to 75, dahil ang middle value natin ang 92, ito ang magiging description ng performance mo in the first semester. And not this mean. Dahil nga may 72, 75 ka. So in rare cases, ginagamit natin itong median value whenever we have very peculiar set or very peculiar elements of in our data set, such as our outliers. So kahit napalitan mo yan, 60, sabihin mo pang 60 yan, o sabihin mo ito 100, hindi magbabago itong median value mo. Pero itong mean mo, dahil nagbago ang values mo rito, magbabago din itong mean value natin. Doon pumapasok yung median value. Okay? So dito sa case na to, no, ang ating mode ay 92 din. At ang ating median value ay 92, ang nagbabago lang talaga yung ating mean. All right? However, no, in many cases and in most of the cases, whenever our data is interval or ratio or in scale measurement in SPSS, no, ang ginagamit natin to describe this set of data is the mean. Okay? So my point, therefore, ladies and gentlemen, is that the measures of central tendency is a single value. Okay? It's a single value that describes our variable. Okay? Single value that describes our variable. Okay? Let's take for example, I am studying the effect of my intervention program in statistics, hypothetical lang, no, on class A and class B. Class A, no intervention. Okay? Class B, with intervention. Now, I will administer the same exam, post-test in examination in statistics. All right? I will administer the same exam. Now, say for example, natapos nila yung kaninang exam. Okay, natapos nila yung post-test. Now, is it practical, okay, that I compare each individual from class A and class B? For example, I would put in my write-up, the intervention program was very effective because Dieter got 17 in class B, while Jerome got 15 in class A. And then Andrea got 20 in class B, and then John Smith got 16 in class A. You know, that's not gonna make sense. Okay? It's not gonna make sense, and that's impractical. Okay? And very unscientific. So what we do now is that we choose a certain measure of central tendency to describe the performance of our students in class A and in class B. So we get a single value that would describe class A and class B, and which measures can help us with those problem. Those are the measures of central tendency. But this again varies in terms of the levels of measurement of your variables. So in this case, no, since we are looking at the post-test scores, and the scores are interval in measurement or scale in measurement, then we get the mean value, and let's say class A has a mean value of 17 or a mean score of 17, and class B has a mean score of 20. In other words, 20 now is an overall description of the performance of class B in a statistics test, while 17 is an overall value. It's a single value that describes now our class A. At yun yung gagamitin natin sa pag-analyze ng ating data. Yun yung gagamitin nating values pag tayo ay nagsusulat na ng discussion and interpretation of data, and not the single values. Okay? Yun ang essence na dapat nating matutunan, itong measures of central tendency, dahil pag kayo ay gumawa na ng research, talagang kailangan yung maintindihan yung mga yan. Alright? So, yeah. So those are the measures of central tendency. Again, it's a single value that describes our variable. It's a demonstration of that is like this. No? See, for example, say we have values 1, 2, 3, 4, and 5. If we get the mean of 1, 2, 3, 4, and 5, we get 15. Okay? We get 3. Okay, we get 3. Now, say for example, this is the score of letter A, student B, student C, student E, D, and E. It's a single variable, it's a single value that describes the performance of all these people. Yun ang essence ng mean. Kahit na 1 si A, pagka i-analyze natin yan, 3 pa rin siya. Kasi nga, sabi nga natin, the mean is a single value that represents or that describes the performance of these students. How do I say so? Kung titingnan natin si 5 kulang siya ng, sobra siya ng 2, positive 2 sa 3. Si 4 naman, sobra siya ng 1. Si 3, 0. Si 2, kulang siya ng 1 para maging 3. Si 1, kulang siya ng 2 para maging 3. Dahil sobra si E ng 2, ibibigay niya yan kay A para maging 3 na siya. Ito naman, ibibigay niya kay B para maging 3 na siya. Ito, hindi na kailangan, di ba? So, ito nabawasan siya ng 1, so 3 na. Ito nabawasan ng 2, so 3. That is why this is a single value that describes the overall performance of these students. Okay? So that is the meaning of the average, or that is the meaning of the mean as a measure of central tendency. Okay? Any question? So yun ang measures of central tendency. That's the meaning of it. All right? So you have to understand that, the concept behind that, because kayo rin ang mamimili kung anong kailangan yung i-measure para i-describe ang inyong data. Now, let's proceed to another important descriptive statistics, which is the measure of variation. Okay? Measure of variation. But before we discuss the measure of variation, I would like you to understand first the concept of normal curves. Okay? Of normal curves. What is a normal curve? A normal curve represents a normal distribution. Okay? It represents a normal distribution. Sir, ano ba kasi ang normal distribution? Ganito yan. Now, for example, we have this graph here. This is our x-axis, which represents the frequency of scores. I should say, y-axis. These are the scores, and this is located in our x-axis. Okay? A normal curve looks like this. Yeah. That is a normal curve. Okay? And it represents a normal distribution. Looking again at this illustration, This is the frequency, and these are the scores. For example, we have scores like 5, 6, 7, 8, 4, 3, 2, 1. In other words, kung titignan natin kung 5, ito yung bilang ng mga estudyante na nakukuha ng score na 5. Samantalang itong 7, ito yung bilang na nakakuha ng score na 7. Parang Cartesian plane lang yan. So this is the normal curve. Okay? Now, always remember that the normal curve has certain qualities. Okay? Pag hinati natin sa dalawa ang ating normal curve, you would observe that the curve is symmetrical. Okay? That the curve is symmetrical. Ibig sabihin, kung anong nakikita mo dito sa kabila, siya din ang nakikita mo dito sa right. Okay? So, kung ilan ang nakikita mo dyan, siya rin ang nakikita mo dito sa left. So, it is symmetrical. The normal curve is also called a bell curve. Bakit siya tinawag na bell curve? Kasi nga, para siyang bell. Okay? Para siyang bell. Alright? It's like a bell curve. Now, the normal curve is also asymptomatic. Asymptomatic daw. Asymptotic. Asymptotic. Hindi asymptomatic, hindi COVID yan. Asymptotic. Pag sinabing asymptotic, kahit na i-extend mo tong dulo ng curve, it will never touch the y-axis. Okay? It will never touch the y-axis. That is what we mean by asymptomatic. Okay? Asymptote to the y-axis. Okay? So, also, itong value na nasa gitna, okay, nasa gitna ng curve natin, this represents our mean, our mode, our median, and our mode. In the normal curve, when your distribution is normal, it suggests people that our mean is equal to the median and it's equal to the mode. Okay? I repeat, no? A normal distribution happens, no? When our mean is equivalent to the median and it's equivalent to the mode. So in this particular example, is say for example, our mean is 5, then our median is also 5, and our mode is also 5. When that happens, we infer that the distribution is said to be normal. Okay? Said to be normal. All right? Naintindihan nyo? So that is the normal curve. Now, bakit ko to pinaliwanag sa inyo? Kasi dapat alam nyo to in understanding the measures of variation. Now, may mga pagkakataon na hindi normal ang ating distribution. Ang kabaligtaran ng normal distribution ay skewed distribution. Mamaya, pag-uusapan natin yan. Skewed distribution. Okay? Let's jump first to measures of variation. Now, napakaraming napag-aralan na measures of variation na na-include sa inyong unit module. Katulad ng range, okay? Katulad ng standard deviation. And also, you have variance. At meron ding MAD, mean absolute deviation, etc., etc. But in research, ang pinaka-ginagamit na measures of variation ay ang ating standard deviation. Okay, which is symbolized by S. Okay, so the standard deviation, S. At ito yung pag-uusapan natin ngayon. Okay, ito yung pag-uusapan natin ngayon. Now, umpisa muna, at firstly, no, ano ba kasi ang measure of variation? Kung ang measure of central tendency, it is a single value that describes our variable, ang measures of variation is a description, okay? It's a description of homogeneity. Okay? It's a description of homogeneity. Okay? Another thing is that it tells us if the data is scattered. Okay? Or it tells us if how wide the values are in the data. Kaya nga yung measure of variation, ang tawag din natin dyan ay dispersion or measure of spread. Kasi tinitignan natin gaano kalalayo yung mga values doon sa ating dataset. Ano ba kasi ibig sabihin ng homogeneity? Pag sinabi nating homogeneity, the values in the dataset are close to each other. Okay, they are close to each other. Pero pag scattered, heterogeneous ang tawag natin doon. So, for example, if you have a dot diagram here, okay, you have dot diagram A and dot diagram B. Okay. Say for example, you have A and B. Which of these dot diagrams is scattered, is more scattered? Is it A or is it B?
B.
Yes, that's correct. It's letter B. In other words, this B is scattered and therefore A is more homogeneous than B. Okay? A is more homogeneous than B because look at this, they are close to each other. They are more homogeneous than B while B is so widespread from each other. Okay? So that is what is being defined or described by the measures of variation. Okay? For example, say doon sa aking experiment, no, so aking research on statistical performance of my respondents of my class A and class B, doon sa post-test nila, okay, halimbawa, no, ang na-compute kong score ng A ay 17.5, while ang na-compute ko sa B ay 17.5 din. Okay, 17.5 din ang score. So, therefore, pag nag-report ako sa principal ko, ma'am, parehas po sila ng performance. Yung A ko, 17.5 din ang score nila. Yung B, 17.5 din ang score nila. Ibig sabihin, parehas sila ng performance sa aking exam. So, you know, it doesn't mean anything, right? Wala man lang twist. Walang spice ba? Wala bang kakaiba na nangyari doon sa dataset mo dahil parehas nga ang mean. Ngayon, kung ganyan, maaari natin tignan yung kanyang standard deviation o yung kanyang range. Tignan natin yung measure of variation niya. Okay? So halimbawa, hypothetical lang din ito Okay, 12, 14, 14, 18, 21, 22. 16, 17, 18, 17, 19, 20. Okay, for example, no, ito yung ating data set. Okay, yung ating data set. Now, if you look at this, what is the range of class A? What is the range of class A? What is the range of class A?
10, sir.
10.
Sir.
So 22 minus 12 is 10. What about B?
4.
4.
4.
So how do we get the range again? We subtract the highest score minus lowest score. So you get 22 minus 12, you get 10. 20 minus 16, you get 4. Now, what does these values tell us? Okay, look at this data set. Which of this class is more scattered? Now, which of this class is more scattered?
A, sir.
A, di ba? Why? Kasi malalayo yung scores. Samantalang dito sa B, malalapit sila. So in terms of scattering, letter class A is more scattered than class B. And if you look at the value that we get for R, which is 10, this is larger than 4. What does this tell us therefore? It tells us that the lesser the value of the range or any of these measures of variation, okay, the lesser the value, the more homogeneous the data set is. Okay? So I repeat, no? When the values, okay, the lesser the value, the more homogeneous your data is. Or the higher the value, okay, the higher the value, of course, you expect that your data is scattered. Okay, your data is scattered. All right. So I repeat, the lesser the value of your measures of variation, any of them, okay, can be standard deviation, can be range, or anything really, okay, it tells us that it's more homogeneous. While the higher the value, it tells us that your data is scattered. Okay, so ano nang pwede mo masabi sa principal dito? O, sasabihin mo ngayon, ma'am, pareha sila ng score, pareha sila ng mean score, kaya lang, napansin ko na mas malalapit ang scores ng Class B. Okay, at ang Class A naman ay sobrang lalayo ng scores. It can tell us na mas malalapit, okay? Or kaya naman, mas parehas ang performance ng B kesa sa A. Okay, mas united ang performance ng B kesa sa A. O, di ba? Dahil nga, mababa ang value ng standard o ng measures of variation. In this case, ginamit natin ang range. So, ang pinakamadaling gamitin na measure of variation ay range. Kaya lang ang problema dyan ay sobrang unreliable niya. Dahil nga, minsan, hindi rin, it cannot really reflect or describe how varied the values are in a data set. So, ang pinaka ginagamit talaga natin ay standard deviation. Okay? We get the standard deviation. And the formula for standard deviation is square root of summation of x minus square over n. Okay? For a population standard deviation. But we're not gonna be andun naman sa unit module nyo yun. Ang napaka-importante lang na malaman nyo, no, kung paano tayo mag-analyze ng data, kung anong sinasabi ng values na ito. Okay? Kasi yun ang i-analyze nyo, yun ang ilalagay nyo sa research. At the end of the day, sabi ko nga kanina, ang magko-compute niyan hindi kayo. We have a statistical program that we will be using to get the standard deviation. But does not mean that you will not submit your unit for module feedbacks anymore. You still have to submit that, okay? That will be part of your grade. But in your quiz and in your exam, situational tayo. There are a few cases na kailangan yung mag-compute, pero most of the time, conceptual questions ang ibabato ko sa inyo. Okay? Now, balik tayo sa normal curve. What is now the relationship of the measures of variation and the measures of central tendency, particularly the standard deviation and the mean? Okay? Particularly the standard deviation and the mean. Now, let me draw again the normal curve. Okay. Ang sabi natin, sa gitna ng normal curve, that is our mean. Okay, this is our mean. Now, nasaan ang standard deviation? Ito ang standard deviation natin. Okay, if we draw another line from the mean, this is positive 1 standard deviation. Okay. Positive 1 standard deviation from above the mean. This is positive 2 standard deviation above the mean. This is positive 3 standard deviation above the mean. This is negative 1 standard deviation above the mean. This is negative 2 standard deviation below the mean. I should say below the mean. And this is negative 3 standard deviation below the mean. All right? Say, for example, we have a data and we computed that is 17. Our mean is 17. And then when I was able to compute my standard deviation, I got a value of 2. Okay, I got a value of 2. So, using these values, okay, yung x bar na sinasabi natin dito, that is already 17. Okay, that is already 17. So, yung score nila sa exam, 17. Now, what score is 1 standard deviation from the mean? What score is 1 standard deviation from the mean? Above the mean. That would be 17 plus 2. That becomes 19. Okay? That becomes 19. Why? Because our standard deviation is 2 and our mean is 17. And if we have that question, 1 standard deviation above the mean, you simply add the value of your standard deviation to the mean. That becomes 19. And what therefore is the value? 2 standard deviations above the mean. So 17 plus 2, 19, plus another 2, that becomes 21. And this is 23 because 21 plus 2. Now, what is the value? One standard deviation below the mean. Well, that is 15 because 17 minus 2 is 15. What is the value? 2 standard deviations below the mean. That is 13 because 15 minus 2 is 13. What about 3 standard deviations below the mean? Well, that is 11 because 13 minus 2 is 11. Okay? So that's how we plot the scores in a normal distribution, in a normal curve. Always remember that this is always equal to your mean. Okay, this is always equal to your mean. Okay, which is 17. Okay. Ayusin ko lang yung mic ko ta may sound, may background noise. All right. Now, so that's how we do it. All right, that's how we do it. Okay, so if your grade is if your score is 21, then your score is above average. If your score is 13, then your score is below average. Okay, your score is below average. Now, there are certain percentages in this area of the normal curve. Okay, in this area of the normal curve. Okay. Now, in the normal curve, from the mean to one standard deviation, either below or above it, it's 34.13%. Okay. While this one is 13.59%. While this one is 2.14%. And this is 0.13%. Okay. So what am I trying to tell here? What I'm trying to say here? It says here, guys, that the number of students, okay, the number of students who are in this area, okay, is 34.13% of the population. Okay, 34.13% of the population. In other words, in a normal distribution, in a normal curve, the students who got a score of 15 to 17 is 34.13% of their population. In other words, kung meron tayong 100 estudyante, okay, sa normal distribution, ang number of students na nakakuha ng score within the mean and a standard deviation above or below it is 34.13% of that number, which is approximately 34. And in this case naman, 13.59. So habang palayo ka ng palayo, bumababa yan. Dahil nga, nakikita nyo, okay, yung area dito, mas mababa kaysa yung area dito sa part na ito. Okay? Now, question. What therefore is the percentage, okay, of students who are one standard deviation above the mean and one standard deviation below the mean? How many percent of students get a score of 15 to 19? What's the answer to that? How many percent of the students get a score from 15 to 19?
68.20.
Okay, 68.26%. Tama si Dieter. Why? Kasi sabi ko nga no, symmetrical ang ating normal curve. Kung ano nakikita mo dito, siya rin ang nakikita mo dyan. So since this is the mirror image of this area here, that is also 34.13. And you simply add this together, you get 68.26%. And that is the number of students or the percentage of students who are between 15 and 19 or one standard deviation below and above the mean. All right? So, if your score are within this, or if your score is within this area, ito yung average area natin. Average area yan. Average. Okay? But if your score, okay, is already in this part of the normal curve, ito na yung tinatawag nating above average. Okay? Above average. And if your score is within this area, ito naman yung tinatawag nating below average. Okay? So, for example, if your score is 20, are you average or above average?
Above average.
If your score is 16, then your score is within the average. All right? So again, you can tell here the position of your score in the normal curve. Okay? The score in the normal curve. Okay, let's proceed. Now, mentioning about the normal curve, no, maraming klase ng normal curves. Kasi sabi ko nga, no, the normal curve can also tell us if the data is spread or not. Example. Okay. We have normal curve A, normal curve B, and normal curve C. Lahat ito ay normal curves, no? Kaya lang, magkakaiba sila in a sense. Okay? Say, okay. So, alam natin, this is frequency of scores, and then in the x-axis ay yung scores mismo. Now, question. Saan sa tatlong graph na ito, pinakamalalayo ang scores from the mean? Is it A, B, or C?
C.
Who is answering me?
Dito, sir.
Oh, Dieter, bakit C?
Kasi ang taas po nung nasa gitna, sir.
Yes, I know that. Look, again, my question is, saan sa tatlong graph na ito, malalayo ang scores from the mean? A, B, or C? Sabi ni Dieter C. Tingnan natin, let's examine that, no? Kung titingnan natin yung graph, no? Andito yung mean natin, tama? This is your X bar. Now, what are the values that concentrates most of the curve? Okay? What are the values that concentrates most of the curve? Oh, are they, di ba, ito, yan? Are they close to the mean? Let's compare it here. Oh, ito yung mean natin. Where are the values that concentrates the curve? In this part, right? Are these values close to the mean? Oh, so Dieter, can you answer again my question? Which of these graphs tell us that the values are away from the mean, are moving away from the mean?
Letter B, sir.
Letter B. Okay? In other words, the values that are very close to the mean are letter C. Okay? While graph A is normally, okay? Siya yung pinaka-normal sa tatlo. Okay? Ang tawag natin dyan, okay, they show us, these three graphs here show us measure of kurtosis. Okay? Kurtosis. Kurtosis tells us of how distributed our data is. Okay? It tells us the measure of distribution, how distributed our data is. So, kung normal distribution tayo, kurtosis yan. Kung hindi, skewness naman yan. Okay? As I have told you. Well, anyway, now, this is what we call a mesoquartic curve. Mesoquartic. Ito naman ang tawag natin dito ay platyquartic. Platyquartic. Well, this one is called leptoquartic. Okay? So we have mesoquartic, we have platyquartic, and we have leptoquartic. So sa platyquartic, kaya siya tinawag na platyquartic kasi nga flat. Okay, flat na nagfla-flatten yung normal curve natin. While leptoquartic, sobrang taas, sobrang steep ng ating curve. While mesokurtic, it's just the normal curve. It's just a normal distribution. Kaya siya meso. Okay? Any question? So, kurtosis yan, ha? Now, previously, I mentioned about skewness. So, when your data is not normally distributed, okay? When your data is not normally distributed, what you have is an skewed distribution. Okay, what you have is an skewed distribution. And there are two types of skewed distribution. We have positively skewed distribution, and we have negatively skewed distribution. Okay, we have positively skewed distribution and a negatively skewed distribution. So how does these two, okay, differ from each other? For example, okay. Now, looking at these two curves here, these two curves are very different from each other, no? Hindi siya normal, right? Kasi hindi siya symmetrical. Pag hinati mo sa dalawa yan, look, hindi parehas, okay? You cannot tell that they are symmetrical kasi may mga parts na hindi mo makikita sa kabila. Now, this graph A here and this curve B here, this curve A is a illustration of a positively skewed distribution, while this curve B is an illustration of a negatively skewed distribution. How can I tell that if the graph or if the distribution is positive or negative? Looking at the tail. Okay, looking at the tail. This is the tail. Okay, yung mahabang part. When the tail is going to the right, okay, because you know if the x-axis is here, papunta siya ng positive, kaya sa positively skewed distribution. So again, when the tail is going to the right. But when the tail is going to the left, okay, left side, yung ating negative value sa x-axis, that is a negatively skewed distribution. At sometimes, no, ang tawag natin sa positively skewed distribution ay skewed to the right. Bakit siya skewed to the right? Kasi papunta ng right. Ito naman, ang tawag dyan ay skewed to the left. Kasi papunta ng left yung tail. Kaya siya skewed to the left. Okay? So, doon sa ating normal distribution, makikita natin that most of the scores are along the average area. Okay, are along the average area. But in this case, hindi ganun ang nangyayari. Okay? In this case, pag sinabing skewed distribution, it's either most of the scores are low or most of the scores are high. Okay? Most of the scores are low or most of the scores are high. Now, looking at this graph, looking at these curves, which of these curves, okay, can you tell that most of the scores are low? Is it A or B?
B.
Why B? Kasi negative. Oh, you see people, hindi lahat ng negative negative talaga. Okay? Hindi lahat ng negative negative din ang ibig sabihin. If we analyze these curves, no, let's look at this negatively skewed distribution. Sabi ko kanina, ano ang nasa x-axis? Yung ating scores. Ito naman yung ating frequency. Okay, yung ating frequency. What are the scores in this area? Are they high scores or low scores? Huh? They are low scores. Kasi 1, 2, 3 yan, di ba? Nagsisimula ka sa 1, 2, 3. Samantalang dito na yung matataas na scores. And what can you say about the area under the curve okay, of this part. Matataas, di ba? Matataas. In other words, in a negatively skewed distribution, most scores are high. Okay, most scores are high. But when the skewness is positive, okay, or skewed to the right, ang area natin, mas mabigat ang area under the curve dito sa part na to. Which we know na dito nagsisimula yung mga low scores natin. In other words, most scores are low. Okay? Most scores are low in a positively skewed distribution. Okay? By just looking at the curves, we can answer that. All right? So I repeat, no? When the distribution is not normal, then we are dealing with a skewed distribution. And in a skewed distribution, it can be positively skewed or negatively skewed. If the tail is going to the right, it means that most scores are low. If the tail is going to the left, it means that most scores are high. Okay. It is important also that this one you should know, okay? Normality, no? We're testing the normality of data kasi pagdating ng panahon, pag tayo ay mag-inferential statistics na, you cannot actually use a parametric test for a non-normal data set. So kailangan i-check muna natin yung normality ng data, kung skewed ba siya o normal ba siya, bago tayo mag-proceed sa inferential statistics na pipiliin natin. Okay? Mamaya, papakita ko sa inyo yung example ng dataset natin sa SPSS at kung paano mag-run ng normality test doon para alam natin kung skewed ba yung data o normal yung data. Alright? So, any question with skewed distributions?
Sir, tanong ko lang dun sa may inferential.
Ano?
Kailangan bang lahat ng data dun, sir, normal, sir?
Okay, hindi. Okay, kaya nga, kailangan natin na matest ang normality ng data. Pag nalaman natin na normal yung data, we proceed with parametric inferential statistics. But if the data is not normal, we proceed with non-parametric inferential statistics. Pero ang ideal talaga, Joms, tama yung sinabi mo, kailangan yung data natin ay normal para mas maganda siyang i-analyze. Alright. Right? Let's proceed to the next one. So that's the measure of variation. Now, last but not the least is the measure of position. In your module, you have encountered there 3 types of measure of position. Percentile, the quartile, and we have decile. Right? So, sa percentile, kinahati natin yung data set natin into 100 equal parts. So, we have percentile 0 to percentile 100. Sa quartile naman, 4. So, we have quartile 1, quartile 2, quartile 3, and quartile 4. Sa decile naman, we're dividing it into 10. D1, D2, D3, D4, D5, D6, D7, D8, D9, and D10. So basically, when we talk about the measures of position, we're looking at the position of a certain value. Nasaan siya with respect to the other values. So halimbawa, no? The Q1 is equivalent to the 25th percentile. Pagkaparehas yan. The Q2 is equivalent to the 50th percentile because you're dividing it just equally, right? Q3 is equivalent to the 75th percentile. All right? While the equivalent of Q2 to the 50th percentile is D5. Okay? The fifth decile is equivalent to your Q2 and to the 50th percentile. Pero walang equivalent itong Q1 and Q3. Nasa gitna ng D2 and D3. Pero hindi naman kasi pwede dahil nga decile tayo, 10 equal parts lang yan. Alright? So ito yung equivalent niya sa decile. So, this measures of position does not tell your actual score. Halimbawa, no, sa inyong CAT, College Admission Test, ang nilalagay dyan ay yung percentile rank nyo. So, halimbawa, 86 ang nakalagay dyan. Ito, 86 percentile. Hindi ito ibig sabihin na 86% ng tamang sagot ay ng mga sagot ay tama mo. Hindi. It's not like that. It tells us that you are in the 86th percentile. You are in the 86th percentile. Nasaan ka ngayon? Andito ka, oh. Somewhere here. You are here. Okay, nandito ka. In other words, yung ibang estudyante na kasama mong nag-exam, they are in this area. Okay, they are in this area. While you are here. In other words, ilang porsyento ng mga estudyante na nag-take din ng exam ng katulad mo ang hinigitan mo if you are 86th percentile. It suggests that you outstanded 86% of those students who took the same exam. In other words, you belong to the top 14% of the examinees. Okay, bakit siya top 14%? Kasi nga, 100 minus 86, 14. Okay, so nasa top 14% ka. Okay? Halimbawa, nasa P99 ka. Yan. So, ilang porsyento ng mga estudyante ang nahigitan mo? 99%. In other words, nasa top 1% ka. In other words, kung 1,000 kayong nag-exam at ang score mo ay P99, nasaan ka? You are in the top 10. Okay? You are in the top 10. Kasi 1% of 1,000 is equivalent to 10. Okay? So, nasa top 10 ka. Kung 99 percentile ka at there are 1,000 students who took the same test. Okay? So, that is what we meant by the measures of position. Sa research, hindi naman masyadong ginagamit ito. But in terms of, if your research is on examinations, testing, and the like, no, standardization of testing, ginagamit nga itong percentile one. Pero sa atin, hindi masyadong ginagamit yan. Okay? So that's just a basic idea of measures of position. It's less complex than the measures of central tendency and the measures of variability. Okay. Now, I'm going to introduce to you the software that we will be using in the next meetings. Okay. No. All right. So before I proceed, since we're gonna be using a software, and I believe that what happened? Bakit 11 na lang kayo? Are you still there?
Yes, sir.
Yes, sir.
Ano nangyari? Ba't 11 na lang? Well, anyway, perhaps they have their own reasons why they're not able to attend our Zoom meeting. But yeah, okay. Jo Marie,
Sir,
I would give you the assignment to give me a list of students who can access a laptop or a computer, okay?
sige po, sir.
Who among you can at least have an access, yung meron or pwedeng makahiram, o at least for whatever way na pwede sila maka-access ng computer. So hindi ibig sabihin na kahit na nawala sila, yun yung i-report mo sa akin. No, you have to report to me kung ilan sa mga kaklase mo ang at least can access by borrowing or by in any way can use a laptop or a computer. Okay?
Sige po, sir.
You have to send that to me 2 days from now.
Sige po.
Because I'm gonna be grouping you in terms of your accessibility to these devices.
Sige, sir.
All right. Now, I'm gonna introduce to you the software that we will be using in this subject. All right. It's called SPSS, or Statistical Program for Social Sciences. Okay. Halimbawa, ito siya. Ito yung tinatawag nating SPSS. Para siyang Excel din. Pero ang Excel kasi maraming functions. Ang SPSS, it's basically designed for statistical analysis. Okay. Now, halimbawa, meron akong study. And my study is composed of investigating the effect of a certain intervention program in the reading skills of students. So, ginupo ko yung students into two, Group 0 and Group 1. Yung Group 0, may sarili siyang intervention program, at yung Group 1, meron din sariling intervention program. So, I gave them a post-test in reading, and a pre-test in reading, and a post-test in reading. And then a pre-test in their attitude towards reading, and a post-test in their attitude towards reading. So, ayan yung data na nakuha natin. No? Yan yung score nila, at ito yung attitude levels nila. Now, kung titignan natin, meron dalawang views sa SPSS, data view and variable view. Now, don't worry, I will upload a video on how to encode data in SPSS sa YouTube. Okay? I am teaching this in the master's degree, and so pwede kong ipanood din sa inyo kung paano mag-encode ng data in SPSS. And I will also upload a file where you can download the particular application, and you can install it in your computers. Okay. So let's talk about this, no? In the variable view, makikita nyo dyan na dapat merong label yung ating variable. So reading scores, and then ito yung attitude. Okay? Yung attitude dito ay nasa ordinal level or nominal. Ordinal siya. Yung nominal din, yung ating group lang. Kasi yung ito ba ay, kung titignan natin yung values, no? Ayan, 0 reading group, 1 reading and drama group. So, yun yung ating treatment. Okay? Ito naman, scale siya kasi score yan. Okay? Score. So, pag sinabing scale, it can either be ratio or interval. Ito naman, dahil meron tayong not at all, not very much, a little, interval, ordinal naman yan. So, nilagay natin dito ay ordinal. So, importante na nilalagyan natin ito. Kaya nga, tinuro ko yung levels of measurement kasi sa lahat ng pagkakataon ay pwede natin gamitin lahat ng measures of descriptive statistics. Nakadepende yan sa kung anong level of measurement ng ating data. Okay? So, yan. Now, what if I want to measure now and to compute now the descriptive statistics of my data? So, I would only click Analyze, and then Descriptive Statistics, then Frequencies, and then ilalagay natin lahat ng data set natin dito. Okay? And then Statistics, mamimili ka ng central tendency. It can be mean, median, or mode. Sa dispersion naman, gusto ko makita yung standard deviation, variance, range, minimum and maximum value. Then sa distribution, yung skewness and kurtosis. Okay natin yan. At hihintayin natin yung resulta ng ating data. Alright. So, meron ka makikitang table dito nagsasabi ng statistics. At andito na lahat, yung mean, median, mode, yung standard deviation, yung variance, yung skewness, at lahat ng measures of descriptive statistics natin. Okay? So halimbawa, dun sa reading score na pretest, ang nakalagay dito, yung mean natin ay 39.68. Sa median naman, 36. Sa mode, 24. Pero sabi niya, ito yung least, okay? Ito yung pinakamaliit na mode. Pero there are multiple modes. Okay? There are multiple modes. Ito naman sa reading score, ayan din nakikita natin. And then, dito, sa how much do you like reading, hindi pwede natin gamitin yung mean kasi interval nga yung data natin, ay ordinal nga yung data natin. We get the mode here, and we can say that most of the respondents answered 3, di ba? Answered 3. While in this case, most of the respondents answered 5. Okay? Ano yung 5? Very much, di ba? Very much na nag-enjoy sila. Pero sa 3, average lang yung kanilang enjoyment sa reading. Okay? And then we can see also the standard deviation here. Now, Dieter, what can you say with the standard deviation of pre-test reading scores and post-test reading scores? Which of these scores is more spread? Is it pre-test or post-test?
Mas spread po yung 13.6.
Okay, so the post-test scores are more spread than the pre-test kasi mas malaki yung value. Alright? Now, tignan natin yung histogram natin. Look at this histogram. Alright? Now, if you can notice, okay? Kung titignan natin to, tignan natin normal curve. Ito yung normal curve natin. What can you say with the histogram, with the bars here? Are they deviating so much from the normality of the data? Compared mo dito, compared natin sa post-test, no? What can you say with the pre-test histogram, Kenneth? Is this skewed or normal?
Skewed, sir.
Skewed. Positive or negative?
Positive, sir.
Most of the scores are low or high?
Most of the scores are low.
Low. Kasi kung titignan natin, andito sa area na ito. Tama? Okay. Jerome, what about this? Is this skewed or not?
Not, sir.
Not. Diba? Kasi nga, may mga nakikita kang graphs na nag-overlap o nag-exceed doon sa ating normal curve. Kaya lang, most of the scores are still inside the area under the curve. Okay, doon natin makikita that the data is normal. Okay, so we can use a histogram to identify if the data is normal. Pero kung hindi ka confident, no? Kung hindi ka confident to identify and characterize if the data is normal, meron tayong ibang way para dyan. We call that test of normality. Okay? Ang ginagawa natin dyan, we just simply click Analyze, Descriptive Statistics, then Explore. We select the data, and then dun sa statistics na button, don't worry to may video ito, no? I-upload lang naman natin din. Okay, may button dyan at cancel natin yan. Pupunta tayo sa plots, and then you simply click normality plots with test, and unclick nyo na yung stem and leaf at saka histogram. Continue. And okay. So, hintayin lang natin. Ayan na. So, lumabas na. Now, meron tayong dalawang measures of normality sa SPSS. We have the Shapiro-Wilk test and the Kolmogorov-Smirnov test. Okay? Kolmogorov-Smirnov test. Now, dito sa Kolmogorov-Smirnov test, kailan natin ginagamit ang Shapiro-Wilk at saka ang Kolmogorov-Smirnov? Now, ginagamit natin ito. Ayan, nakikita nyo itong test of normality. Ayan, okay. Now, when the sample size is less than 50, I repeat, when the sample size is less than 50, gagamit tayo ng Shapiro-Wilk test. Okay? But if the sample size is greater than 50, gumagamit tayo ng Kolmogorov-Smirnov test. Now, in this case, no, how many sample size do we have? What is our sample size? It is 60, right? And if that is 60, then what test shall we use? Is it Kolmogorov-Smirnov or Shapiro-Wilk?
Shapiro-Wilk.
What?
Shapiro-Wilk.
Yeah, we use the Shapiro-Wilk. Are you sure? Ito. Okay, remember 60 60 when our case here, our number of cases here is 60. Now, ang sabi ko, when our sample size is less than 50, we use the Shapiro-Wilk. But if our sample size is greater than 50, we use Kolmogorov-Smirnov. So if that is 60, what shall we use? Kolmogorov or Shapiro-Wilk?
Kolmogorov.
Yes, we use the Kolmogorov-Smirnov test of normality because our data uses sample size of greater than 50. Okay, so dito, let us focus our attention on the significant value here, yung sig value dito, sig. Now, remember, okay? Kung paano natin makukuha ang normality, paano natin masasabi na normal siya, when the sig value is less than 0.05, it's said to be normal. Okay? It is said to be normal if it's less than 0.05. But if the sig value is greater than 0.05, it is normal. Okay? I repeat, no? When the sig value is less than 0.05, it is not normal. If the value is greater than 0.05, it is normal. Look at these reading scores. Okay? In the pre-test, ano masasabi natin? Is it normal or not normal? Dieter.
Normal, sir.
Is 0.00 less than 0.05?
Sure, saan po na part dyan, sir?
Di ba itong sig value, titignan natin yan. Okay? If the sig value is greater than 0.05, it means that the data is normal. But if the sig value is less than 0.05, it means that the data is not normal. What is the sig value for reading scores? And we use Kolmogorov-Smirnov here.
Not normal.
It is not normal. Why? Because it's less than 0.05. What about the reading score post-test?
Normal.
Jo Marie.
Normal, sir.
Normal. Bakit?
Sir, kasi 0.200 lang yun, sir.
Greater than 0.05.
0.05.
Kung babalikan natin yung ano natin, histogram natin, 'di ba? Sabi ni ano kanina, sabi ni Jerome ba 'yun o ni Kenneth? Sabi ni Jerome, this is positively skewed, 'di ba? So hindi siya normal, yung pre-test. Tapos itong kabila naman, this is a normal distribution, yung post-test, which coincides with our findings as given by the test of normality by Kolmogorov and Smirnov, 'di ba? So yung pretest natin hindi normal kasi nga less than 0.05. Yung post-test natin normal kasi it's greater than 0.05. So kung hindi ka confident sa pagtingin ng histogram, ang gagamitin mo itong test of normality natin. Depende kung anong sample size natin. So Kolmogorov-Smirnov or Shapiro-Wilk test. Now, there is another way that we can look at the normality of data. Ang tawag natin dyan ay normal QQ plots. Okay, normal QQ plots. Now, ang normality, based on normal QQ plots, makikita natin kung gaano kalalayo itong mga plots natin, itong dots natin, itong circles na ito, dito sa line of normality. Okay, kung makikita nyo, may mga nagde-deviate from the line of normality. And that suggests that the data is not normal. Ito sa pretest to na-conclude na natin na hindi siya normal, which is true. And we can see it in the normal QQ plots. Kung titingnan naman natin ang normal QQ plots ng reading score post-test, no, ayan. 'Di ba? May pagkakaiba. Tignan niyo yung normal QQ plots niya. Malalapit na doon sa line of normality. So this suggests therefore that our data is normal. Okay, our data is normal. Naintindihan nyo?
Yes, sir.
Okay, ito nakikita nyo na yan, those are outliers, yung mga malalayo sa line of normality. Let's have another example, no? This is another data set. Kukunin natin yung result ng score dito sa parang entrance test to. So let's get the normality. Let's test the normality. So ayun, na ano ko na. Again, just plots and then normality plots with tests. Then kunin natin yung histogram kasi hindi natin nakita kanina. Okay. Madami yung data, no? Kasi 1,000 plus yan. Ayan. So how many cases do we have? What is the sample size? Jerome, what's the sample size? Look at this table. What's the sample size?
So ako na.
Yes, Jomari.
Sir, ay 1,450.
Okay, very good. 1,450. Now, if we look at the test of normality, anong gagamitin natin? Kolmogorov, Smirnov, or Shapiro-Wilk?
Kolmogorov.
Okay, Dieter, what can you tell with the normality of data? Is it normal or not normal?
Normal, sir.
Normal or not normal? Dieter, 0.00 yan, oh. Anong sabi natin?
Sir, di ko po kasi masyado nakikita, sir. Sorry po.
Okay, sige. Jomari,
Sir, not normal.
not normal kasi it's less than 0.05.
0.05.
Dieter, ito na lang. Look at the histogram. What can you say with the histogram? Is it skewed or normal?
Skewed, sir.
Positive or negative?
Positive.
Most of the scores are low or high?
Low, sir.
Okay, good. Kenneth, are you still there?
Yes, sir.
What can you say with the normal QQ plot? Normal or not normal?
Not normal po.
Bakit?
Sir, maraming mas malayo dun sa linya. Sa
Okay,
line.
very good. Therefore, are these tests coinciding with each other? It's not normal. It's skewed. So therefore, it's not normal. And then the test of normality would suggest, therefore, also that the data is not normal because our sig value for Kolmogorov-Smirnov test is less than 0.05. All right. So that is SPSS, and that's how we look at the normality of our data and how we run descriptive statistics there. There are 7 among you survive. Bakit kaya? Siguro nawalan ng kuryente sa kanila, no? Anyway.
Nawalan kanina sa...
Siguro. Okay, I understand that. So, panoorin na lang nila tong video na to sa YouTube because your quiz will also be based on this discussion. All right? So, we end our discussion in that matter and yun lang. Joms, huwag mong kakalimutan yung assignment mo sa akin, ha?
Sir, yung quiz din po, sir, is on Friday to Monday.
Yes, Friday to Monday din.
Statistics lang po.
Yeah, yung discuss ko. Tsaka yung sa module nyo.
Sa may AOL, sir, wala na po muna to.
Ay, meron, syempre. Magdi-discuss tayo sa sa Thursday. Wednesday, no? Bukas, no? May discussion tayo bukas.
Sige po, sir. Thank you,
Alright.
sir.
So we'll see each other again tomorrow. Alright. Okay, we end this discussion this afternoon. I hope that you have learned a lot. Although wala yung iba, gusto ko na please chat your insight, your reflections, your learning experience today. Dito sa Zoom natin mismo. I'll give you 5 minutes to do that. So please, what are your reflections for today's discussion? What is your learning experience of today's discussion? So chat that in the chat in the Zoom. Okay? I'll give you 5 minutes to do that. Okay, go, proceed. Last 2 minutes. So don't forget no, i-upload ko sa sa Facebook page natin yung file na SPSS. Install niyo yun sa ano niyo sa inyong computer, and we will be using that for future discussions. All right, so I guess we are done. Goodbye, everybody. And to those of your classmates who were not able to attend today, let them watch the videos na lang. Okay? Bye-bye and have a nice day.
Thank you, sir.
Goodbye, sir.
Bye.
Thank
Thank
you
you, sir.
po.